All right. So, how's it going so far?
Struggling.
Good. Could we go over the homework? The class
There it is.
work 11?
The homework 11?
Yes, please.
Yes, I got a 1,000 emails from people who have trouble doing the project. Not only for one single person, like a lot of concern. So I extended the deadline till Thursday, so you guys can
Oh,
have,
thank God.
yeah,
Thank
you guys
you.
can have work it out until that you feel like it's good to submit them. So again, continue from here until the rest of semester. If you have any um, specific issue, just let me know. You have to email me. I got people who cannot finish the exam because their connection sucks. So you need to email me of that as well. So let's say, and then when you submit the file, make sure that this have to be in terms of the JPG or PNG or PDF file. So those file that I can read them. And so out of that, you're gonna delay your grade a little bit. So anyone who, again, that there was still a couple of you guys who submitted the files, but sometimes you need to put data solutions so that I can't grade them fast for you guys. Other than that, I have to grade person by person and question by question. So it's gonna take really long to finish the grading. And if you get the correct answers, that will be very easy for me to give you full credit for that. But if you get the wrong answers compared to the system that it tells, and so I have to recalculate all of that. So it might be a little bit problematic for me. I mean, if you get it wrong, give you 0 point. That'll be easy. But since I will also take into account the work that you guys submitted, so it took me a while to finish one single grade. So we have 26 members in this classroom. So meaning that it took me around 26 days to finish it. I'm just kidding. I'll be finishing grading all of that by tonight. And if you have anything that you want to see a grade, or you haven't seen your grade, you have to let me know as well.
Yeah, I haven't, but I emailed you. I'm pretty sure you know.
Yeah. So if you email me before, and you should be able to receive that grade, unless you haven't really emailed me.
Remember I sent you the PDF yesterday version of it?
PDF yesterday. So yeah, so you're gonna wait for a while.
Yeah.
Yeah. So I tried to read your file. I think Anthony, right?
Yeah.
So I finished grading 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 questions. We still have 8 questions left. So it took me a while to reorganize all of that. So that would be a thing. Okay.
No rush. Thank you.
Yeah. So if you want to see a grade, I'm gonna shoot you an email for that as
All right,
well. And
thanks.
there was still around 6 to 7 people that either your work as a little bit mad. So if you start from question 1 up to 21, and that'll be easy for me to grade. If you start from 1 and then you jump to 14 and you jump back to 7, you trying to play around with me. That would be cool. I love that. But I never take waypoint, but it might take me a little longer to finish that. So just be patient. So I would really appreciate it. Okay. So I believe that we have done some work, right? And let's check them out for that part. I uploaded. So all of you who have trouble, let's say, get the file. So it should be on chapter 7. And so this is the SL file that we're going to use. I'm sorry, chapter 6 and 5, I apologize. 7, you don't touch them anyway. 7, just for understanding. So let's say for those of you who have trouble with the project, then you go to this file for chapter 6 and this file for chapter 5. And that's pretty much the thing that we need to do. Other than that, we're going to go over some project. I got one person who emailed me saying, "Can I go over project question number 3?" Correct? Right. So let me just go over that real quick. Let me just search on the SL file. I don't use SL for often for this laptop, so generally. So it sucks. Anyhow, Excel is not as good as other data processing files because it's just good for accounting generally. So now this is all we need to do. For example, I want to have a data. So I got one person saying that I can't get the data analysis. So if you cannot get this one, just email me. For example, I don't see the data analysis on the Excel file because I'm using Windows. Some of you, I mean, many of you are using Mac, and if you can't get this out, and I shoot you an email. It's very simple. I just type it on YouTube how to get data analysis on Mac, as you're gonna get it. So anyhow, and this is what we're going to be doing. So first step that we're going to look for the prices. So let's say the company going to be having a certain prices. So let me just go through the prices for the one single company for that part. So let's say I took Yahoo Finance, I believe. Yeah, you can go invest.com, but this is literally the thing that you might need to get through that. So this is, I would say, I would go for Tesla. I would go for Liso. This is what people buy a lot. I believe, but it's not. It's just a brand name for that. So Tesla company, basically using the same prices that we have done on the first project, and you don't really change them, right? So for example, um, I go to historical data sets and I click on it. So assuming that we forget what it is, and this is how you're gonna get the how you're gonna get it back, and assuming that we want to do the weekly prices, so we're gonna go for weekly, and you click apply, and to see whether or not you can download that. So let's say we don't have them, forgot what it is, and so this is pretty much a thing that you need to do by going from the prices. You don't really have to keep the volume. I mean, I have some friends who actually analyze a lot of volume pressures, the volatility along the way, but we don't deal with that, right? So this is pretty much like a different story of statistics. So we only deal with the prices. I mean, if you want to do the volumes and how much they trade per week, per day, and you want to see how it's going to affect the prices, we can do that, but definitely not going to be on this semester. So, and after we get it done again, that we going to get rid of most of the column, except for the adjusted prices where they ended on at that day. I'm sorry, on that week. So can get rid of everything else. So it's not going to be like something is really much for this part. But remember that the first part will be the most recent price. So again, most of you actually doing something different on the project. So you got to be really careful by that part. So this is what we call the time, right? So we call the week. And so the week one would be the most recent one, and week two that would be the last week. So and then you're gonna drag down, and assuming that we forgot what to do, again that you're gonna need this part for the part three, and making sure that you're gonna keep them. And I would say this is the for the prices. Okay, so fair enough. And then now we're gonna compute the return. How can I compute the return? The return will be the change, the rate of the net change over last week prices. So we're gonna take this week price, I would say, and minus last week price, and I divide it by last week price, so we can see how much they change, whether they're gonna increase or decreases. So this week they increased by 9% compared to the last week. And then we're going to do that for every single one. Okay, so let me just repeat that again. Except for the last one, you cannot do the last data set because we don't have enough information or for that. Okay, we just go up to here. You can get rid of it if you want to. We only need that Route 50 data set to make sure that it is it is normal. So now we going to have the returns right there, and you can literally check that you can see the change for the price changes. So last week we dropped from 22% up to 21%, and you can see the prices for those week coming up. Okay, so the returns, uh, this is what we call the weekly returns. Uh, you can say that. If you don't, if you do the daily prices, that's perfectly all right. So after we get the prices for the return, then we're gonna go up next. We're gonna go to the data analysis, and of course, we're not gonna go with the random number generator. It is where we want to generate a certain random numbers for that part. I mean, it's simple, but we're not gonna use them. So we're gonna go to regression, and for the white input, I think we need to have two prices, right? We need to have two prices. So and let me just take another prices. I would say I'm gonna go with Intel. So and we're gonna do the same thing. Go to the data sets, and I'm gonna go to where is it? The prices. I don't know. I'm gonna get the prices here. Um, oh, okay. Your list is empty. It's good. It sounds good. Okay, and so you can see that you're gonna go to historical prices. We're gonna do it one more time, and then just copy and paste for that part. I mean, just do it over. Literally no big deal. So, we're gonna click apply, and let me see if they add the dividend. So if they add the dividend for that part, you're gonna split them up into a different folder, a different file for Excel. So you gotta be really careful. You're not gonna paste it on using the same file. So we're gonna do it again, the same thing, copy and paste, and we're gonna get rid of the column that included dividend. We're not gonna do that, right? You're not gonna include that part. And so you do the same thing for this. Okay, so that's pretty much a thing that we need to do. So, and after that, we're gonna get rid of all of this column. Okay. So, and we're gonna keep the last one, which is called the adjusted. And after that, we might want to post it right here on Excel. No, we're gonna copy and paste it. Okay. So let me just copy and paste for that. All right, so it seemed like it. And let me just name all of that. I want to make one more column. This is for Tesla, and this is for Intel. Okay. So, and now after we get these two columns, the next part is that we're gonna go to data analysis, and we're gonna go to regressions and the white range. So again, that we testing on the return for each part of it. So it doesn't necessarily have to be a certain thing. So you can put that the first one, right? And we don't really have to include the label for that part. Oh no, I haven't really checked the return for this part. So we're gonna go for the returns, and let me go for the returns. This is what we call the prices, and this is for the return. You do the same thing for this. You're gonna take that minus this and divided by this. In fact, the Intel actually not decreasing that much. It's doing pretty well, except for the last one. And now we're going to do the data analysis, and let's check them and see. Okay, so regression, we go do that again. And for the white range, we do the first column. I mean, you have to test on the rate, because it's really important to see whether or not the rates follow by the normal distribution. right? What do you care about the thing when you do the investment? Money. The money matters, right? I mean, who care about the prices? Want to see how much it changes, whether or not it's follow a certain rule. So after that, we're gonna get the output. I want to get the data set done on this site, and I click on normal probability plot, and pretty much it. I click OK, and basically you're gonna have a plot. It doesn't look so good at all. So this is what we call the normal probability plot for both of these prices. And it doesn't seem to be normal, but there will be some of I was called the outliers. Those are the things that we should get rid of for the regression. But anyhow, the central point I would say is relatively normal. Okay, so I mean the deep analysis is not as easy as we have right here, but this is what we can tell, that the data set is basically not normal at all. It's more like it's not more like a straight line, but they all connected, but it's not going to be good. This is not the only way that we can do it. There's another way, but I got rid of it. This is the easiest way that we can do for the project. So, and then this is what we call the weekly return. Returns. Okay. So, pretty much it. Any other concern? Any questions about the project so far? So now we're going to work on the classwork. Do we agree? So let me just do here. We call this as a sampler project. Okay.
Sorry, Professor, I had a question about the regression table.
Yeah.
So I got like a regression plot, not a normal probability plot. So does that mean I have to do it over again? Or do you remember seeing my project?
Yeah. So I have no idea how you're gonna get two plot. Maybe you have full prices. But you're intuitively correct. What I'm saying, yeah, it will be recorded. What I'm saying is the fact that
Did you do the package? The package? Yes, thank you.
what we usually have to check them is no package. It's hard to deliver using. Yeah, trust me. When you order something, it took 2 weeks time, whatever it is. Okay, so what I'm saying is that normally that we need to construct. So you're gonna change all of these data point into the z-score, reorganize them, and put it on a plot to check each model. But since the Excel, they have the built-in function that they can check both of them at the same time. So we can see that it is somewhat easier for us to check for the return for both of the Tesla and Intel. So generally, this is easier. I'm not going to construct like two plot for two z-score and then put them on the model to check whether or not it is a straight line. So using that normal probability plot is helped me test on the both prices at the same time when we compare them. Okay, so that's pretty much a thing.
My normal probability plot just looks a little different.
It should be different. It cannot be the same for all.
No, like as in like, you know how the sample percentile goes past the 0 point?
Yeah.
So mine does not do that.
It doesn't matter. So because it's including, I would say it's also when it converted, it's also including the negative and the positive plot for that part. So meaning that you might have some negative score and positive z-score along the way.
Maybe Sunday I talk to her, I remember.
Okay.
Okay, thank you.
All right. So anyhow, and this is basically the thing that we need to do on project part 2.
Mm-hmm.
I'm currently having the project part 3 as well. So that'll be the last part. So I really want you guys to get full points on the project. If you get 10%, that would be great. If you mess up the third exam, or if you mess up the second exam, that's not going to be something really traumatizing for us, especially when it comes to the final. To be completely honest, the final exam is the one that I feel the most difficult part. The reason why I would say the final exam the hardest part because it's include all the chapter from 1 to 15. So it's not going to be as simple as we dealing with 3 chapter from 5 to 6. I'm sorry, from 4 to 6 or from 1 to 3. So we have to go from 1 up to chapter 14. So it's not going to be easy. So what's going on for that part is I'm gonna post the solutions for classwork number 11, okay? And I also got some ideas saying that should I go over the questions
Right.
classwork number 11, and I would say okay, but since we don't really have much time to do so, how many days left out? How many days do we have before? Before, let me see. Okay. How many days left do we have before the final exam? So today and tomorrow on Thursday we're gonna finish cover chapter 8. Okay, so 21, 23rd, 21st, 23rd, and 28. So that will be around chapter 9 or 10. Okay, chapter 9 and 10. And 30, and after that, so that'll be 11, 12. So for 7 and 12, so that'll be 15, 14, 15. That's pretty much it. So we don't really have time. What is the final exam date? The final exam should be on May 15, right? Am I correct?
14th to Thursday.
Is it 14 or May 15? I don't quite remember.
14th is a Thursday.
Yeah, so I don't think we have enough time. I feel like we need to jump the lecture a little bit, and let's see how fast. I'm planning out to give you guys 2 final reviews. So the first one will be on 7 for sure, and then the next one will be on 12. And before that, how many days left? 1, 2, 3, 4, 5, 6. Okay, 6 lecture to cover 8 chapters. Well, that's gonna be a little bit rush.
8 chapters and 6. Whoa.
I was kidding. We skip chapter 11 and chapter 13. 8. Yeah.
Do we still have the quiz Thursday?
Do we have a quiz on Thursday?
Yeah,
The answers. How many quiz that we have done so far?
I think 4.
3.
Is it 3 or 4?
Thought it was 4.
I have no idea.
I believe I haven't really checked the grade yet, but I can't check the grade because you guys are here. So let me just double check. The quiz. We haven't done any quiz yet. So so the quiz definitely gonna be what do you like? You want multiple choice or you want just the short answers question? What do you think?
Multiple choice kills us, right?
It's basically, I don't know. I can give like 20 questions. it's
Yeah, I thought there was gonna be like 3 questions, like the last time.
I would say 1 question. The quiz should be 1 question.
Oh,
if you prefer a short answer for that.
Yeah, if it's 1 question, just make it a short answer, I guess, right?
Yeah. So other than that, I can give you guys like 100 question multiple choice on a final exam.
No thanks.
Each question gonna be 1 point. It's gonna be terrifying. Anyhow, so and also when I give multiple choice question, you can't get on Google. You try to search them, it never works. I have a test generator. It's literally just go against the Google search for that. Anyhow, so again, that the quiz will be on Thursday.
And we don't have to submit it till Friday at 6, you said, right?
Yes, we're gonna submit it until Friday, 24 hours. So when you start a quiz, you're gonna have an hour and 30 minutes. What do you think?
Okay.
Right, fair enough. You have 1 hour and 30 minutes. Unless you sleep on the quiz, there's no way that you don't have enough time to finish that 1 single question for that.
Sorry, so it's on Thursday?
It will be on Thursday. The quiz that will be on chapter 7.
And then it'll be available after class is over?
Yeah.
Am I available?
No. He's saying, when will it be available after class? Like
after class, right after Thursday class.
And then we have 24 hours to
submit it. So
Yes.
Okay.
started from 8 p.m.
So Friday 8 p.m. you have to submit.
until Friday 8 p.m. So we basically have the full period, 24 hours. So when you click on it, so I keep track the statistic view. How many people they thought I don't have them. It's very simple. I can collect all of that information using Blackboard. So so I can use the control panel for that part. So making sure that when you click on it, please finish it and submit them by an hours and 30 minutes for that part. And if you I got some questions saying that people don't know how to submit them, or you can use a cam scanner, or maybe you can email yourself, or maybe you can use a Hadoop file for that part. They just automatically convert it to the PDF file. I got one student and in Cal 2, and she said, well, I mean, all of your tools are very ineffective because of what? Because your phone already have the file, the built-in program that can help you convert it to the PDF in one single in one single action. So I feel like it's more effective when you have something like that. But anyhow, I don't mind if you use a certain thing, but make sure that when you submit them, I'm able to read them and grade it along the way. So, any concern? Again, there were still 6 people who I haven't really finished grading. I apologize for that. So since I have a lot of issues going on with the files and the chapter summary, so today we're going to go over chapter 8 summary, right? So this is going to be something that we're dealing with the first chapter of statistics. So this is just the beginning of statistics. So we started from chapter 7. It's part of it, but chapter 7 actually the most important chapter because it tells you how the sample mean looks like in statistics. So the normal that go with the sample mean, I'm sorry, the curve, the model that go with the sample mean is the normal distribution. So this is the reason why the normal curve is super important. So it's just like how people model, like, the Bill Gates says that how he modeled the coronavirus cases is basically doing the same thing, but they use a different program to iterate to basically repeatedly summarize what the curve looks like using the machine learning. So it should be different from what we learn. Of course, is more high level of that. But generally, what we have so far would be the thing that we just finished it. So, all right. So now let's go to chapter 8, I would say. Again, we have the classwork for today. So the classwork will be on this part. So if you can finish it, that would be fantastic. If you can't finish it, you can wait until next week. So all the classwork here will be extended until Thursday.
Sorry. So is classwork 12 due Thursday?
It's due on Thursday. I mean the entire week. So I'm not planning out to give you guys a lot of work during this stressful time.
Sorry.
And
So it's due this Thursday or next Thursday?
this Thursday. I mean,
Okay.
sorry, at the end of the weekend, so you can submit it.
So it's
by
due
Saturday.
Sunday.
Yeah, I don't even put down the date for the due date for that. I believe that you can submit it
Anytime.
anytime you want to. But
Okay.
of course, you're not going to submit them after I put the grade on on the portals. That doesn't make sense. So, but generally, please try to submit them the classwork 12 and 11 and 12. I want you to keep track of them when I grade them, and if you submit them after I post a solution on it, I usually post the solution a week after that. So I do not count the grade. Okay, I do not count the grade when you do so.
So are we not going to go over classwork 11 now?
I can't go over it. If you want to.
Please.
I wouldn't say it is a very difficult questions. Which question that we have trouble with?
All of them. Wait,
All
you're a
of
stats teacher. Of course this isn't hard for you.
Well, I mean, I don't do a lot of stat, to be completely honest.
Wait a second.
To be completely honest, I don't deal with stat too often now. Yeah, so my job has very little thing to the stat right now. It's more about the returns and the things. But anyhow, the stat is really cool. The stat is the first part that people usually have to learn. So generally, this is what we have to do, assuming that we have oops.
Wait, so then if you did it and you're doing it now and we got it wrong, can we resubmit it?
I guess so. I
Oh.
guess so.
Okay.
I think
Okay.
you have to resubmit them.
Can we even resubmit it? Like, is that even possible? I don't think so.
Well, I mean, I give you guys 5 attempts. What do you want?
Ooh! Okay, 5 attempts is good.
Cannot make this class as easy as it seems to be completely. This is the easiest way that I can make the class simple. And to do the problem, and you know, you guys can redo them. If you still get it wrong after I do the problem, I got nothing to say. I mean, it's basically impossible to get it wrong if I even redo them. I mean, there's some cases that people still get it wrong for some reason. If you ask me why, I don't know. I mean, it's just the way that we do it. Anyhow, so this is from the classwork questions, and I do appreciate you guys can see the screen. And so again, how many questions will be on a final exam compared to according to what we have learned from chapter 7? That will be 2 questions. Okay, each question going to be 4 points, so 2 separate questions. So making sure that it should be 8 points or 8 or 9 points for that 2 problem, maybe 10 points. So just don't underestimate the later chapter because the final exam. So some people would say, well, I mean, I'm doing pretty well in the first 2 chapters. And I'm sorry, I'm doing pretty well in the first 2 exam. And then it's already 6 chapters. And I can't just let go of the rest of them and try my best to do a final exam. The answer is never work. I have some students who are doing really well on the first 3 exams, still fail the final exam. That's sad, but I mean, they still pass the class. Before that, I got people who did like 85 on the second exam and did 35 on the final. It was really sad to hear. But at that moment, the math department basically imposed on a policy where I cannot pass a student with the people who finished the final exam lower than 40 points. But now they got rid of it because
So we have to get above 40 points?
not necessary. You can get 20 points to pass if you did 100 in the first 2 exam. I mean, that's impossible to get 20 points. I never seen people who got 24 on the final. I mean, there was maybe 1 or 2. It was a really sad story to tell. Anyhow, that person took the class 3 times, and he will be losing his job if he cannot pass my class. But there's nothing I can do. He came to the class sleeping the whole day, the whole time. What can I do? I don't know. And so again, this is what we have to do. So the questions gives us, again, the questions for chapter 7 asking us to do the probability. So this is a thing that we need to deal with, right? And the question also gives us the mean, which is 25%, and the standard deviations, which is 8%, I believe. And so now we need to do what we need to figure out a probability. So the probability that we call the P, right? So this is the P, and the mean rate that we call the X bar. Correct? So it's about between 20 and 30%. So between meaning that, so we're gonna rewrite the questions, the probability of X, about between 20 to 30%.
Oh, sorry, quick question. So in terms of the final like exam, like for the second exam when we got the review and then you went over or like you had us like do all the review questions and then you gave us the answers for them, will you, for the final exam, will you give us a final exam review that goes from chapter 1 all the way to now?
Yeah. So
Okay, great. Okay, thank you.
usually I never done anything like that except for this semester. And Asmus, I think I never did anything like that. But yeah, I did not have time to do so. But I feel like it's gonna be better so that you can see what the focus of the exam looks like. So if you can do pretty much the same questions, you should be able to do well on the exam as well. So I learned from my past mistake, and I did not really have time to do something. In other words, I was a little lazy for that. So, but I believe I put more understanding than doing a problem. So I feel like it's. I mean, there was still a lot who got an A, or A minus in my class last semester, but there was also a number of people who did not do really well because, you know, anyhow, they underestimated the final exam. So, so this is the probability where we converted from the X bar from the mean rate, right, up to the Z score. So, the overall tax rate was 25%. 25% wasn't that bad, but it wasn't good either. I think the people who do less than 75K, they have to pay around that amount. I forgot what the tax looks like, but anyhow, the bracket changed every year and every presidential campaign for that party, so they might change it. So the standard deviation 8%. So all we need to do, we need to convert it to the Z score for both of this. Do we agree?
Yep.
Yeah. So the question also gives us the n equal to 16. So this is important. On the exam, a lot of people, they sort of feel like they converted, but they do not really multiply by radical n. So this is completely wrong concept, right? This is the X bar. We're doing the X bar. We're not doing the Z score for the population. This is for the sample, right? So I randomly picked 16 people, and I want to see, hey, what are the chances that they file the tax to pay around 20 to 30%? What are the chances I can get that? Well, this is coming from the sample. This is not the population. So we need to take the n into account, meaning that when you do the conversion, it shouldn't be like really complicated. But again, that I expect people to do it on a calculator. So the first thing that we need to do is that we're gonna do 20 minus 25, and we divide it by the standard deviation. That would be 8%. This is also the thing that people usually ask me, why don't I convert it to percentage, from percentage to decimal number? The answer is you don't have to, because when you take 20% minus 25%, this is also in terms of percentage. And then when we divide it by 8%, so the percentage and percentage, they're going to cancel each other out. So we don't necessarily have to do so. But if you insist on doing that, that's fine. That's great. But I don't take away point for sure. And sort of thing that we need to do, that we multiply by radical n. So remember that this is a thing that we need to do. Okay. So, and the calculator going to helps us do something like that. Let me just use a calculator real quick. Again, if you don't have the VA83, please download it. Expired anyway, who cares? Now, the thing that we're going to do in this case was, let me just get rid of this. So I'm gonna take 20 minus 25 and divide it by 8, correct? And times radical 16. Do we agree? Right, so we're gonna get negative 1.25. correct? I'm sorry, at negative 2.5, right? So this is the thing that we need to put in down. It's right here. So this is negative 2.5. Okay, similarly, that we do for tax 30%, we basically get the same thing. So the z-score for 30%, you're gonna get 2.5 for sure, 100%. So we're gonna take 30 minus 25 over 8 and multiply by radical 16. And then we multiply by radical 16. So we're gonna get 2.5. Okay. Anyhow, so we're changing the z-score from negative, oops. Okay, and this one is positive 2.5. Okay, so after that, we just basically use the chart, correct? So the table that we're going to have here, just read from 2.5 to positive 2.5. And you're gonna take, so 2.50, so that would be 0.9938, right? And subtract negative 2.5, 0.0062. So what we need to do, we're gonna take 0.9938 minus 0.0062, and we're gonna get the answers, which is 0.9876. Okay, so that's pretty much the thing that we need to do for the first question. And there's nothing else. And if you get when you resubmit the classwork number 11, if you submitted the wrong answers compared to the answers that I have right here, shame on you. Okay, there's nothing I can do. Same way for question number 2. So question number 3 will be a little more challenging. Question number 3 is actually a lot more challenging than compared to the question number 2 and 1. So let me just do question number 2 right here. Question number 3 right here. I have enough space. You need a draw a line for that, right? No crossing border for that part. Now, so we're gonna have question number 3. That sucks. Okay. All right. Okay. So now we have these questions. Do we agree? So the school is required the government to give some randomly chosen student a standardized test. From the previous experience, the school knows about 68% of students will receive the passing score in math and English. Wow, that's going to be very low. To improve the funding, the school needs to score at least 70, right? Wow, you want to be greedy for that. Very ambitious. So I want to get 70. This year, the school can decide if it wants to test 100 or 200 students. Should the school test 100 or 200 students? Explain the answers. What do you think?
Is this the one where you have to do z is equal to 0.70 minus 0.68, and then over the square root of like the rest of it?
The rest of that, and then we convert to the z-score, and then we do that along the way. Okay. So for this type of question, I'm gonna do the end. Again, the school knows that the P overall, the P that people pass, the P of the passing is 0.68, and I want 70%. Of course, you want to choose fewer people, right? Right? Correct?
Oh.
Okay. Anyhow, so let's take the p of passing equal to 0.68, right? And then what the question is asking to do, we want to get the p hat. So we want to get the p hat at least 70, so greater than 0.7. Okay. So all we need to do in this case is that we're going to convert it to the z-score. So the conversion is literally the thing that we need to do with for different n, correct? So let's say we take the n equal to 100 student and see how it going to be, how it going to look like. So now let me just take the n equal to 100. So what do you think? So so the z-score that we're going to contribute to that questions will be what? So we're going to take, so we convert to the z-score of 0.7, right? I'm going to take 0.7 minus 0.68, correct? So this is the p hat minus the p. And this is the p hat. This is what I want. I want 0.7 this year to get the funding. That's really doesn't make any sense. That doesn't make any sense. Why people always want to get like 70% of people passing the class? That doesn't make sense. I want 90%. Okay, so and then we're gonna take that and then divide it by the square root of we're gonna take the same thing. And I'm not gonna do for n equal to 200 because you gotta go and do it yourself. So we're gonna take and after that we're gonna take 0.68 times 1 minus 0.68, and then we divide it by 100, right? So this is the step that I should draw like right here. And then we divide it by 100. So this one was a little bit tough for us to do so. And, but anyhow, this is what we need to do. So on a calculator that we're going to take 0.7 minus 0.68 over the square root, right? The square root of 0.68 times 1 minus 0.68. I mean, just do it and divide it by 100. And then after that, we close the parentheses, right? And then we're going to get the answers, which is 0.23, right? And so this is going to be 0.43, I'm sorry, 0.43. And after that, we just do the same thing for this part, that'll be 0.43. And then we just read the chart on the table. And so the chart that we're going to use, that'll be table number 3. So 0.43 that we can see that is go to 0.4 and 0.03. So that'll be 0.664. So the answers for this part would be equal to 1 minus 0.664. And so when we do that, I'm going to take 1 minus 0.664, and that's pretty much it. So that'll be 0.336. Okay. And so if we want to pick 100 students, the chance that we're gonna score at least 70% will be around 34%. So if they choose 200 students, you just change the denominator, right? Instead of 100, you change to 200, and then you're pretty much getting the same thing. But of course, different probability. So and then whichever gives you the bigger chance to win, we're going to pick that. All right. So anyhow, so if we pick 200 students, we're definitely gonna get the biggest Z score. If we get the biggest Z score, meaning this guy going to be big, and the change will be lower. So very likely, let's say the change that you can win, that you're confident to win, is lower than what you want to get. Take a small number. This is always be the case. So anyhow, we finished chapter 7, and now we're going to go for chapter 8. Any concern? Any?
Sorry. So you would want to pick the lower percentage?
Yes. No. No. You want to pick the smaller group of people. You're not gonna, because the confidence is 0.68. I want to get something higher chance. I want to get something bigger. So you have to pick a small number of people.
So you'd want to pick 100.
You want to pick 100 students generally, because when you do n equal to 200, you're gonna get this guy's bigger. If this guy is big, and then we read the chart, this guy is going to be bigger. So 1 minus something bigger than that, you should get something less. So that's the reason why, if you want to score at least 70%, so we need to pick that part for sure.
Oh, it's still 6.8. Oh, but you have to do it for 200. Okay.
Okay.
And then you have to subtract it still, right? So like, because I did it for the 200 people, so I have to subtract it
By 1.
which is like 72.91. I have to subtract that by 1.
Uh-huh.
Okay, got it. Thank you.
So you're gonna get a lower percentage for sure, correct?
Mm-hmm.
So what that
Yes.
means, right? We cannot be so greedy. So it's basically, it looks counterintuitive. It's very intuitive things that we need to do statistics. So the chance I can win is low, and I want to get something with a big chance. I want you to reach to the big chance. Of course, you have to pay less, right? So you have to think of it a little bit. Yeah. I have one student is doing the intermediate statistic that he can explain his concept really, really well. He going towards the game theory, and where people have to play around with a certain thing and with a certain scenario for that part. But anyhow, this is what we have for chapter 7. Now we're going to deal with chapter 8, I believe, and let's see how we're going to go towards that. So chapter 8. Oh my goodness, we spent more than an hour for chapter 7. That's unreal. Anyhow, so this is about
Your fault,
chapter.
Justin.
Yeah, this.
I'm trying to learn, bro. I'm trying to learn out here.
Okay. So let's me go to chapter 8 real quick for that part. And homework chapter 8. Yeah, this is what we have. Okay. So what is a chapter 8 generally? This is the first chapter of statistics, and a lot of you thinking, well, a lot of you think, what is statistics generally, right? The statistic is basically helps us understand, not just to understand the model, right? The reason why we need to understand the model because we want to get the best information at hand. We want to know what it is and how we're going to utilize the information to test on the entire jungle, right? It's just like when you pick out a few samples, how those samples going to give you a big reflection on that jungle. So that would be the key point of doing statistics. It's just not the way that we look at it, and just not the way that we imagine it, okay? So for chapter 8 is where we're going to estimate the value of parameters. So what is that? It seems to be something that you never heard of. So what does it mean by parameters? So the parameter is basically the jungle information. Let me just do that here. Parameters. Oh my goodness. Let me just rewrite them. Parameters is basically the population's information. Okay, population information. Okay, and so this is what we trying to get, the jungle. And what is statistic? Statistic is generally sample information. Okay, this is like some type of them, but the sample have to be the representation of population. If that is not representation, we cannot use them. So this chapter, we're trying to estimate a jungle, right? We're trying to see what it is, but you never know what the jungle is because in some sense, you can know something about a jungle, but you never get like the whole information of that because we don't have the data set, right? We just pick out a few sample and see what it is. We study on it. But do we truly understand what the jungle looks like? The answer is no. Okay, so all we need to do is that we're trying to shed some light and see how this population going to play around with this. Okay, in other words, what we need to be doing for chapter 8 is literally we're trying to estimate that jungle using a sample information. So this is what the jungle looks like. We call N. Okay, the N is the entire jungle that we're trying to avoid. There's no way they can understand what it is. It's just too big to count generally. So all we need to do now is coming from a small sample. I would say, so we're gonna shed some light for the sample we call small n. So started from chapter 8. Started from chapter 8. You always be given by the small n, no matter where you go, whatever the question that you have. Very likely that if we want to investigate the core problem of any single thing, then the ends always comes along. So in this case, that we're going to have this guy would be called the X bar. And this guy and the S. Okay, so for the big populations that we have right here, and this guy, we're going to have the mean and the standard deviation. So what does it mean by that? The jungle that we use these two parameters. The first, this one we call mu. I don't know how to read them correctly, so this is one of the Greek letters. And another thing that we call a sigma. Okay, I mean in calculus 2, in calc 2 that we also use some as well. This is also called a sigma as well, but we don't do it very often. So this part would be a thing that we see it in statistics, but these two numbers usually unknown because those are the jungle information. So now the statistic is, all we need to do is I'm going to test out the jungle using the sample information. Okay, so this is what chapter 8 about. And all of this we call qualitative data sets. I'm sorry, quantitative data. I mean, can we only test this, the means? Can we test something else? Can we test on the volatility of that? Can we test on the postman of that? I mean, you can do a lot of things, but the basic chapter that we're doing here is basically on chapter 8 that focus on the population mean. So in other words, for this chapter, we're going to use N to estimate, in other words, to estimate the mean. So we want to estimate this guy. That's it. We finished chapter 8. Generally, every single chapter is just work like that. This is the most important thing. Okay, so basically we should write something like that. Yeah. Anyhow, this is all we need to do. Okay. For chapter 8, again, before we started, the estimation should be in terms of the interval. So that's a reason why we call estimation. Okay, so we call it confidence interval. So the confidence interval basically provides the range of the values with a certain level of confidence contain the true value, contain the mean, the population mean of the corresponding population parameter of interest. So it looks a very, very complicated situation, but it's not really complicated. So let me just, let's say I estimated, there will be 3 estimation for that. Let's think of it, 3 estimation. The first, I estimated the mean of the final exam, for example, right? We haven't really taken any final exam yet, but let's say I estimate the mean between 40 and 80, okay? So that would be the first estimations. And then the second estimations will be between 80 to 90. Okay, so the first one should be 60 to 100. And then last one, I want to estimate it between 40 and 100. Okay. So can somebody tell me what is the best estimation that we have? Remember that what are we trying to do? So the population mean should be contained in that interval. Okay, so all we need to do is we estimate the range. We don't know what the value is. All we can do is we're trying to know what the range is and use that information to make some conclusion based upon that. Okay, so now we have 3 estimation between 60 and 100, 80 and 90, and 40 and 100. Which one going to give us the better information? Which one going to give us the worst information? Okay, I heard some music noises and someone talking as well in the background. Okay, all right.
Lower numbers give us the better information.
I'm sorry?
The lower numbers?
Not the lower.
Oh, higher numbers. Sorry.
So which one do you think?
Probably
I thought
80, 90.
90. Yeah.
80 and 90, right?
Yeah.
Correct. So yeah, this is actually the best estimation that we have.
Is it because collectively it's equal to 170?
It's not about that. It's basically tells us something. So let's say I predict the final exam average. Remember that we can only predict the average for the entire MAP 117, right? It's not for our single class. Will be between 80 and 90. What does it mean? The estimations consider ranges. Yes, the estimations have to be in terms of the range because we can't do it that without using a range for that part. Unless we're doing hypothesis, so that would be on chapter 9, and so this will be a thing that we'll be doing next. So so when you look at the range between 80 and 90, what I can tell is that the average on the final exam of MAP 117 between 80 and 90, so that will be around B minus to A minus, right? So this is a thing that we can justify the answers for that part. But if I can tell you that, hey, my mean is between 40 and 100, what does it mean? It doesn't mean anything, right? In this case, I would say the worst estimations. So we can tell anything about 80 point to 100 point. So the average score of the final exam for all the students of MAP 117 can be 41, right? Can be failing, can be all 100, can be all passing, but there's no clue that we can justify the answers. Similarly for 60 and 100, but at least this one is okay estimation. I can see that all people pass the class, right? So from 60 to 100, it can be 61, the average. It can be 62, it can be 70, it can be 80, it can be 90, it can be 99, right? So the estimations going to narrow down the information, and we want to see how this information going to help us justify the answers. That will be the most important thing. So the broader the range, the less information that we get, right? So let's say the U.S. economy is expected to lose between $1 trillion to $10 trillion. I mean, this one everybody basically know what it is. But if you say the U.S. economy is expected to lose between $6 to $7 trillion, that makes more sense, right? So we know what the range looks like. It tells you a lot of information, and considerably, that's going to help us make a decision based upon that. So this one is basically the worst estimation, but it's not the worst, right? This is the worst, but it's not the worst one. Anyhow, yeah. So we want to get like a very decent range, so that we can basically justify the answer along the way. Remember that there's no way, there's no clue that we can get the actual value for the average of the population. So, so all we can do is basically estimate it, because we don't know how many members in the jungle. How can we compute the average in that jungle? There's no way. So the only thing that we can do in statistics is we trying to set up the guard. Okay, the guard means the estimation, the bow, and you can try to locate that bow with a certain confidence. So this is what we need to do in statistics. Okay, so statistics is literally it pretty much about controlling, you know, the informations and how we're gonna set them up. Anyhow, this is for chapter 8. Any question? Are we good? This is about chapter 8 for quantitative data set. This is the whole definition. The other thing just doing math. But the concept is really, really important. So, based upon that, what we can do is we need to deal with the confidence interval. Okay. So confidence, what is the confidence? And what is the confidence interval? So the confidence interval is, so what is the, so for example, when you look at that estimation, I would say I am around 90% chains. I am 90% confident to tell you that the average for map 117 is between 80 and 90, right? 90%, that's pretty good. And I am 95% chance to tell you that my estimations for the average of map 117 will be between 60 and 100. And I'm basically almost like 100%, 99.9% chance, 99.9% confident to tell you that the average should be about it between 40 and 100. I mean, the bigger the range, the more confident it is, right? So this is what we call the confidence interval. So when we look at in terms of intuitive thinking, the confidence interval is just the confidence, the tolerations, the confidence level of that statistics. Okay, so so in order to write down the information, we just literally just do something like that. So the confidence interval is the change, the probability. In fact, it is the probability that, or the, I would say the validity of the test of the estimations level. Okay, so usually people would use the confidence interval to justify the answer. So let's say I have 95% confidence to tell you that the mean should be bounded between 60 and 100. So 95% is pretty good. If I say that the average score, I am around 60% chance to tell you that the average should be bounded between 81 to 83. I mean, 60% is not that good. right? So, meaning that we have 40% chance that the thing will go wrong way, the thing that we go off from the bow. So, so we gotta be really careful when you use the confidence interval. But there's nothing wrong that people use 20% confidence or 30% confidence. It just sometimes it's just the thing that sometimes we cannot use them in statistics, right? When you make a decision for that, if you only not 30% confident that the mean should be between 81 and 83, it doesn't make any sense at all, right? So we still have 10% chance that thing will go wrong. In other words, so the confidence interval is basically the thing that we have right here. That would be the probability evaluated using this. Okay, so there are basically 3 common confidence intervals. So in order to make the estimation valid, the statistician, they use 3 common things, 3 common confidence. So the first one is 90%, the second one is 95%, and then the third one is 99%. So all of this will be on it, on the exam. So if you ask me, why don't we use 80%? I mean, 80% is basically too low, right? Because there'll be 20% chance that the thing will go wrong. I don't want that to happen. So so literally people prove in statistics, they prove that 90% is the standard. If you study the CFA exams, so they actually have a question asking us to prove why 95% is the standard percentage for the confidence interval. I mean, there's a lot of justification for that, but the good thing is we don't have to justify that, right, for this class. The only thing that we need to know is that we realize there will be 3 percentages. The one would be 90%, the second one 95, and then the third one is 99%. Okay, so I'm gonna copy and paste here. I'm gonna draw this. So how we're gonna estimate that is basically follow this trick over and over again, every single case. Let me just do that. So how we're going to estimate that. So this is what we call the range, okay? Basically, this is the range for anything. If you want to estimate for the mean, estimate for the population, standard deviation, everything have to be something like that. So this is what we call the range for the population mean. Okay. All right. So what we have to be doing is that the X bar would be called the unbiased estimator, will be the center. So X bar will be the unbiased estimator. So if you ask me, hey, how can I estimate the average for the population? Of course that we have to use the average for the sample, right? Because the way that we compute the average for the sample, pretty much the same way that we compute the average for the population. If we just add up all the data set divided by n, they work exactly the same way. But one is for the entire jungle, one is just for small pieces of the information that we collected. But X bar will be the unbiased estimator that we're going to use this at the central. So of course we're going to control the error bell. You remember that the broader the range, the worse estimation will be, right? So meaning that maybe we try to narrow down, and there's no way I can narrow down the error bell, but we can control it. But what I'm saying is that it's based upon the error. So in statistics, if somebody told me that error is not good, the answer is no. The error is important. The error is critical when we're dealing with statistics. So in every single case, the error bell is always be the thing that would justify it. The errors is also associated with the probability, the chance that things will go wrong. Okay, so in this case, the error bell will be coming from the X bar minus the errors, and X bar, you add the error, as simple as that. Okay, as simple as that, what we have right here. Okay, so pretty much, if the questions gives us this guy, the population standard deviation, but this pretty much not going to be on the exam. Very likely not going to be on the exam. So make sure that we don't study that much on this 8.1 because it's impractical. What I'm saying is that, well, I mean, people in the past, they actually use this type of informations. So people back in the day where we haven't really developed statistic until one student, only one person, one student from England, he published in the newspaper saying every single claim that you guys doing, including all the professors from all the university doing so far in statistics was completely wrong. Then he justified the answer. So, but anyhow, but this information is going to be very helpful for it. So the error bell can be computed by taking the z-score. So what is the z-score? The z basically follow the normal distribution curve. So this is the normal curve, right? Okay. And we multiply by the standard deviations. We multiply by the standard deviation. And after that, we divide it by radical n. Okay. That's it. I mean, why the error bell is corresponding to the normal? Because the normal curve is basically based upon the confidence interval. So it's have to be proportional to that. And then the error bell is also correspond to the standard deviation. This is what we learned from chapter 7. Hey, what is that? This is basically the march of the sample error, the standard error. Okay. So it looks really confusing at what it is, but you can think of it. You can think of that the error bell is literally proportional to the standard deviation, because the bigger the standard deviation, the unpredictable of the data set will be, right? So when you have like a really big standard deviation, so it's going to be really hard to control the data set. So the error bell will be big. But it's basically disproportional to the n. So what does that mean when the n, when we collect more data set, what happening to the error bell? So when we collect more data set, meaning that the error bell is going to be smaller, right? So that's very intuitive. When you have more sample, let's say instead of taking 10 sample, now I'm taking like 100 sample, 1,000 sample. What happened to the error bell? The error bell will become very, very small. When the error bell become really small, what happening to the range? The range will become very small as well. The estimation will be better. So that works because when we think of it, the more sample that we have, the more information that we get, the better decision that we make. So this is basically what statistics is about. So when you get more sample, when you get more information, of course, the estimation is going to be better, right? So that's pretty much the thing that we need to do. So let's do one example, and I would call it a day. And again, that I did not really feel so good for today, but we're gonna come back to this chapter 8 on Thursday. So I will be grading all of your guys' exams, and if you can email me, if you don't see your grade, you can email me, and I will send you an email back for that grade. Except for Anthony, because he sent me it before, but I really haven't really looked up the grade yet. I mean, I graded 13 questions, but still take a little bit long to do so. So let's go over questions and see how it looks like. So the life expectancy for the Bostonians is 78.1 years. I did this question last semester, and there was a girl, she was like, oh, I'm so happy because I'm from Boston. Okay, that makes sense. The average life expectancy for Bostonians is 78.1 Massachusetts. Assuming that this average is based upon the 50 sample, right? And then assuming that we know the population standard deviation is 4.5. And then I want to construct a 90% confidence interval for the population average life expectancy of the Bostonians. So So this is all we need to do first. Let me just do it right here. And let me just copy the questions and let's do them together. And for this part, I mean, it wasn't that bad, but just the way that we do so. Okay. And let me just make that a little bigger for us to see them, right? So the keyword for that would be called a confidence interval. The confidence interval is really important because this is always going to see on chapter 8. Okay, so now we're gonna look at that. The average that we have here is 78.1, okay? But this is not the population average. This is just the average for 50 people, the 50 Bostonians for that part. And then we also have the population standard deviations. And now we need to construct 90% confidence interval. So, so the information that we're going to use, so the X bar, let me just change the marker a little bit. So the X bar that we have would be culture 78.1. And we have the standard deviations would be 4.5.
Wait, what is this problem from?
This problem is basically from the chapter summary.
Okay.
Yeah. And I mean, what are we trying to do? We're trying to estimate the average life expectancy for the entire Massachusetts people of the, I'm sorry, for the entire Bostonians community. It's not only for 50 people, but data set that we use basically based upon the 50 Bostonians. And so what we got right there for the standard deviation is 4.5. And we also have the confidence interval. That would be 90%. Okay. And the confidence interval we call CI. I don't, if you ask me why I use CI, because the C represent confidence, I is called interval, so I use CI. Some people use CIA, but that's cool. Okay, so we got 90%. And after that, all we need to do, we need to compute the E, which is called the error bar. Remember, the error bar will be the first thing that we need to do. Some people can skip that. So some people can just do some. I'm going to show you how to do them. So the error bar will be the Z times the standard deviation, right? Times the standard deviation over radical N. Okay. So all we need to do now, we're going to go to, what is the Z? So the Z will be the number that we're going to look up to the table number 3B for the Z-score, but usually that you don't see them. I mean, you still have to use this table for 8.3, for chapter 8.3. So if I look at 90%, I can literally see, is it 90% or 95%? It's 90%. So when it is 90%, so I forgot to put down the sample n equal to 50. This is my bad, I apologize. So n in this case equal to 50 people. Right. So when I do that, and I look at table number 3B, I can get that the Z-score is 1.645. So, and I'm gonna take 1.645, I multiply by the standard deviations. So the standard deviation that we got here is 4.5. And then I divide it by radical n, which is radical 50. And we got the answers right away. Okay, radical 50. And so we're gonna use a calculator for that. We're gonna take 1.645. oops, let me just delete that, times 4.5 and divided by radical 50. Okay, and a close parenthesis for that, and the answer is 1.046. I take 1.05. I take 1.047. I mean, 1 year is actually not too bad. 1.047. Okay, so now, and we're going to estimate the mean. So the mean would be x bar minus the error and x bar at the error. Okay, so, and that's it. That's pretty much finished. So I know some of you maybe not very familiar with this way. We can actually make it shorter for that.
Sorry, quick question. In terms of the x bar, we have to solve this, right?
No, the x bar is given, always be given in this case.
Okay.
X bar is 78.1 minus the error is 1.047, and we have 78.1 plus 1.047. And again, that we can do it in a calculator. In this case, that we can get just do it on a calculator. So 78.1 minus 1.047 and 87.1 plus 1.047. So that would be 77.053 and 79.147. Okay, that's finished. And so if you sort of feel like, well, I'm not doing that way because if it's hurting my eyes when I look at the screen like that. Do we agree? You can say something. You can do something like that. So x bar plus and minus z times standard deviation over radical n. Are we good? It's just another way that we can write, right? Another approach, another way. I mean, you don't really have to be working on the error and then just write them there with x bar minus the e and x bar you add the e. In fact, we can just say, I'm going to take x bar, which is 78.1, plus and minus the z-score is 1.645, right? And multiply by 4.5, and then divided by radical 50. So, yeah, we're not getting married for today for sure. So we're gonna get like 78.1 plus and minus 1.047. And we're gonna get this. Right? We're gonna get this part. We're gonna copy and paste for that part. Oops. I mean, it's just the way that we do it. It doesn't matter. Okay, that's pretty much it. Yeah. Which way that you feel like is simpler?
I think the second way is easier.
I mean the same thing, but I break it down in terms of the error. And,
I like the first one.
You know, this is basically the error value, right? I just compute it separately, and then I just add and subtract from the x bar, and it's pretty much giving me the same answer for that.
Can you go back to the error chart?
Yeah. Go back to what?
The error chart that you used?
Not the error, the table, right? The table
Yeah.
that we have is right here, table 3B.
Thank you.
Yeah, so if we use table 3B, you're gonna get the z-score, but very likely that we're not gonna use this concept because on the exam, you're very likely you have to work on this part. Why? Because I mean, how the heck possible that if the question gives you the population standard deviation, it doesn't make sense. Because in order to compute the population standard deviations, we need the population mean. Hey, no, yeah. So my dog barking. So in order to compute the population standard deviation, we need the population mean for that. But since we don't have them, so that's pretty much impossible to do so. So that's the reason why I call this guy impractical, because it's literally not helping us to solve any problem. However, this is basically the good practice for us to deal with the example. And so for the next day, when we're going to deal with the t-score, when we have to deal with the population the sample standard deviations, and this is how we're going to proceed that. So now let's go to the part B of the questions where we're going to be working on the second part. I think I did only the first part. Yeah, I apologize. So there's no part B. Anyhow, okay, we finish it. Okay, and so we start the lecture here. And any question, any concern for that part?
No.
Okay, so that's it. That's pretty much for today. Before we leave, I think I should take attendance.
I have a question. So can we hand in the homework again, like resubmit?
Can we resubmit the classwork? This is what you mean. I
Yeah.
don't want to sign any homework problem. So the answer is yes, you can resubmit them and try your best to submit it before the final exam. I'm sorry, before I post the solution on it. Okay, so so we're gonna do 10 and 11. So this I would basically finish chapter 8 on Thursday, and then we're gonna do 8 again. And after that, we had to go for 9 and 11 and 12. So that'll be 11 and 12 will be focus. 8, 9, 11, and 12, and 14, and 15. And so it's gonna span around maybe 30 minutes for 14 and 15 for that part. But the focus, the hardest part that we don't understand would be basically on chapter 9. Okay. Anyhow, so we're gonna take attendance, and I hope that you guys really enjoy the shelter in place. And I'm just kidding. You guys really enjoy the weathers and the things that we have right here. So let me just check if people was absent here. We have 1, 2, 3. We have 21 people, but meaning that we have 6 or 7 people who was absent. Let me just check. Okay. Wire. All right. So let me just see. Isabel is here.
Yeah, hi, I'm here.
You're here?
Yes,
Oh,
I'm
I
here.
don't see your name. I'm sorry. Yeah,
Oh,
sorry.
it's too bad.
Yeah, too bad. Okay. We have Diane's here. Debbie's here. Danner's not here. Yeah. And Yesie's here. Oliver.
Which one?
Which one? Oliver Winter.
Yeah, I'm here.
Oh, you're here. Okay, that's fantastic. And TNZ.
Yeah, I'm here.
Yes, you absolutely. Auburn's he's not here for sure. I know the reason why, but anyhow, Leon's here. Yeah, so his absent. Yeah, is here for sure. But yeah, absolutely. So that's pretty much it, and I wish you guys going to have a great day. and stay safe, stay cool, stay healthy, and we'll see you guys each other again on Thursday. Have a great day.
Thank you, Professor.
GG's. Thank you, Professor.
Oh, actually, Professor, I had a personal question.
Yeah.
In regards to the email that you sent me,
Yeah.
would you say I'm closer to the bottom end of the spectrum or the top end of the spectrum? Because you said I was at between the two grades.
This is really hard to justify. This is just the estimations that we have for the grade. But since I don't know yet because the final exam due 40%, but up to now, this is what I can tell. So I would say will be the top one. Okay, that's fair enough.
Okay. Thank
Yeah.
you very much.
So I can resend you an email for that reason.
Yeah, could you?
All right.
Because it's just because like I have to because due to current circumstance, NYU requires like
Okay. Yeah.
emails. From professors
So
and stuff,
we're gonna bring it down by email. So yeah.
Okay, great.
All right.
Thank you.
Okay. So stay cool for everybody.
See you Thursday.
Professor,
Have a
I
great-
also
thank you.
sent you an email a week ago. If you could respond to it, that'd be great.
Okay. That'd be great.
Sorry.
All right. I apologize for that. Sometimes
okay.
we didn't have time. Okay. All right. So have a great night, everybody.
Too.